We should be good to go. This is right here. Yeah.
All right, some great talks so far. This has been really fun. So my name is Randall. I manage the digital imaging division here at the museum. And today I'm going to be talking about fluid collection and photogrammetry. So for those of you not aware about fluid collections, these are also called wet collections in natural history museums. They are specimens preserved in ethanol, isopropanol, glycerin, and these comprise a huge amount of our natural history collections. When we're thinking about fish collections, herpetology collections, huge amount of aquatic invertebrate collections, these are preserved in fluids. And to a lesser extent, you have smaller collections of ethanol or fluid-based mammals and birds. And here at the Florida Museum, we have around 4 million specimens preserved in fluid. So for us, trying to come up with a really good way to create photogrammetry models of our fluid collections is really important. So we do a lot of photogrammetry already of dry collections. Here are some examples of that. We just finished up a big project doing all freshwater mussels of North America. So we produced photogrammetry scans of 330 freshwater mussels in collaboration with U.S. Fish and Wildlife, the Smithsonian, and Chesapeake Bay Foundation. And the way that we do our high throughput photogrammetry is we use this designed 3-camera system paired with a turntable. So this is an automated system. Every time the cameras fire, the turntable turns or vice versa. And the way that we do the modeling is we'll do a whole 360 rotation of a specimen. And then after that 360 rotation is done, we'll flip the specimen, do a whole another 360 rotation, and then all of our imaging is complete for that. And this is what that looks like. So we have, this is in the reconstruction program. We use reality capture primarily. So we have these 3 circles. Those are our 3 cameras. And this is the dorsal or top view. And then we have the bottom view over here. And so the alignment program or the reconstruction program does a really good alignment with all this. All these tiles that you're seeing are the actual photos that were taken. And then we can go through the rest of the process that a lot of us are already familiar with for photogrammetry, doing the alignment and then meshing and then using the photos to create your texture. The problem is with fluid collections is that they are not solid objects. They have a lot of flexibility to them and they move a lot. So when we try to do the same approach and we try to flip our specimen between the 2 imaging sets, what you get is a lot of motion. So here the turtle head is shifting over on your left side, and this is problematic because when you don't have the consistency, the alignment stage, and the reconstruction program has no idea how to mesh this object. And as a result, you get huge chunks for the misalignment that are missing in your meshing process, and it doesn't really work that great. We've also experimented some other techniques where you kind of hide portions of the object that might be more affected to movement, like this, like hiding in an ethafoam and then flipping it out. And, you know, for the most part, it actually kind of works. But then you do get these real issues with texturing. So part of the ethafoam was then used in the reconstruction program and mapped on the head. So, you know, while it works, it's not really efficient because there's a lot more post-processing that's involved to clean these models. So this is where this system, new system that I put together comes in. This is now in our fluid collection building, which you guys will be able to tour tomorrow. And I'm gonna just talk a little bit about it. But the main takeaway is that for this system, our objects are not flipped. So we avoid any of those chances where the object might move or shift during those 2 image orientations. Now it's just 1 image orientation. So this is with a 3-camera system because this is macro. We're using macro lenses on this. You didn't need a 4th camera. But overall, our new system is 4 cameras. So you get a nice options for angles from the top and below. And so the rotary table, instead of traditionally, it might be at the bottom on an actual table. Here we have it inverted, hanging from up top. We have our 4 cameras, and then our specimen is hanging from that. We use aluminum wire right now, and we're still experimenting with different attachment types, depending on the weight of the object that we're trying to model. And if folks have suggestions for this, love to chat more about it. And then we include our scale bar, which is done a lot for traditional photogrammetry so that it is actually real scale to size. And here's an example of some of the models that we've created out of this. I will note that these frogs here were used with the macro setup with the 3 cameras. And I think we're getting really good detail. And one of the takeaways here is that the modeling is actually really fast for these with minimal post-processing. And the setup really lends itself to really oddly shaped specimens, especially really large things with long tails. So those you can't flip, right? If you flip those tails are going to move position. It's going to make reconstruction or alignment really hard. And then stuff are, we have a lot of fluid specimens that when you take them out of ethanol, their shape completely changes, right? So like this frogfish, you put it on a table, its belly is going to be totally flat, and then vice versa. When you flip it, it's going to be really hard to do this traditional flip on a rotary table setup. And the setup also lends itself to doing some other cool things like insect collections, which are pinned usually, and they can be hard to do on a tabletop setup. We have the capabilities now to do macro with the setup, getting really good resolution, coverage, also doing somewhat of stacking, but we're not actually stacking all the images. We're more so just doing a couple of different orientations or rotations, I should say. And it also provides opportunity. Well, us here, we can't really see this fluid preserved rat, but it lends opportunity to start 3D modeling things that we wouldn't traditionally think of doing, like these fluid mammal collections or bird collections, and also lends itself to doing now specimens preserved in glycerin. So if we're interested in analyzing the differences between parts of an object that are ossified versus cartilaginous. So I'm just going to go over some of the system pros, some of the cons. I'm going to look this up real quick. All right, so the big pro is that you don't have to flip the specimen, which is great. Because it's a multi-camera system, imaging is way faster, which decreases your time of drying out these fluid preserved specimens, right? You have a fluid preserved specimen out of the jar, it's going to dry, which is problematic. Not only because it would damage the specimen, but also from a modeling point of view, parts of the object are going to start shrinking, and so the alignment is going to change. And also because we are positioning things now vertically rather than horizontally, you are getting much better coverage of the focal point. So for an example, with this 4-camera system, we've also been playing with what's the maximum threshold for the number of degrees that we can get away with while still retaining a good amount of resolution, both in our mesh and texture. And we found that we get really comparable results if we image every 8 degrees versus 5 degrees for the rotation. And this, with our 4-camera system, provides 180 images in around 3 minutes, which is really great for fluid collections. So here's just illustrating what I mean by a better point of focus. So this is our point of focus in the center. If we have a specimen on a table, especially elongate specimens, which are really problematic, your center of focus is going to be more in the center. And then if the distal and proximal ends of the specimen, they can easily go out of that focal range, where when you set the specimen up vertically, it's all going to be in that more so centralized point of focus, which is really great for creating models of elongate specimens.
Time check.
Time check, okay, almost done. All right, so cons, right? All these setups have particular cons. What are ours? So snakes are very problematic so far. We're still thinking about ways to solve for this. I think we do have a way to do it, but also really want to talk with folks hopefully tomorrow about some ideas for this. Glare, imaging anything out of fluid, glare is going to be an issue. And then in general, fish fins are really hard to model because they are so thin and they're usually transparent, which photogrammetry does not do a great job with. All right, so for glare, I think we solved this issue. We just use polarizer filters. Sometimes we do cross polarization, where we put polarizer filters on our light, and this takes out all of that reflection. Here is an example of what that looks like. On the leaf, you don't have polarizer there, you get all that shine, and then when you put the polarizers on, it gets rid of that. So that's been really great, check for that. So that's not really a big issue, but the really big issue is fish fins so far. We do have a way to fix this, but I don't think it's a really long-term efficient way to do this because we do want to do mass production of these models. But currently what we're doing is we'll run the object in the software, fix the fins in Blender, all this stuff, and then rerun it through the software again, where it reapplies the texture on the fixed mesh. So also really would like to discuss with colleagues here on some potential ideas of how to get better coverage of the specimen and hopefully maybe fix some of the issues with capturing the fins. So maybe check, not really. So last but not least, I just want to give a shout out to the fluid collection imaging crew here. They've done a great job. And they have been producing a lot of these fluid collection models that you would see on our Sketchpad page, which please check out. Here's the QR code, and special thanks to funding sources, the Florida Museum, ID Bio, NSF, and the U.S. Fish and Wildlife Service. So thank you very much.
Adams.